Hi guys, if you enjoyed the last video, please like, share, comment, and put on your notification button so that you can get an alert when the next video is dropping. Thank you so much. So today we'll be talking about motion, motion in physics. I put it that way. Yeah, motion in physics. And just from the word motion, we can also call motion movement, you know. And for example, if we look at an object, let me say this is an object at point A, it moves the distance to point B. Now, this movement can be regarded as motion. Now, if you look at this, well, when this object started moving, it covers a distance at a particular time. So there's a particular time, period of time it takes for it to move from point A to point B. So from this my explanation, we can define motion as the change in position of an object, as a change in position of an object with time. Just like I explained, now there's a movement. Let me draw something irregular. Okay. Now there's a movement from point A to point B. Now there's a distance covered, right? Now let's assume the distance covered is 80 meters. Now there's a time taken to cover this distance. Let's say the time taken is 5 minutes. So this is basically what motion is all about. So motion is the change in position of an object with time. Now we have different type of motion in physics. The first type of motion I would like to start with, types of motion. So we have different types of motion in physics basically. So first one, we have random motion. Random motion. Now I will explain each of them one by one just as I list them. So random motion, from the word random, it means something not regular. Not regular. We have something disordered. We can put it that way. Something disordered. Yeah. So random motion is just movement of an object irregularly. It does not have a specific direction. Doesn't have a specific direction. It is just moving irregularly. It does not have a fixed point. It does not have a destination. It's just moving irregularly, disorderly. So an example of a random motion. Example of a random motion. I think smoke particles, you know. Another example, we have something like motion of gas in the air. Motion of gas in the air. So if you look at the motion of this when you blow is smoke, or when there's a smoke coming out from the exhaust of a car or a vehicle, if you look at if you can just take a look, you can imagine the kind of movement is irregular. Same thing to the motion of the gas in the air. Another type of motion I would like to talk about is translation motion, translational motion. Now this kind of motion is kind of popular. It's mostly what everybody is engaged in every daily activities. So if you look at this motion is different. It's just the opposite of random motion. Random motion is not regular. So this motion is regular. That is, That is, there is there is a direction. There is direction. Uh, Also, that is, there is there's order in the movement. There's order in the movement of the motion, or of the particle. Let me put it that way. Yeah. So, for example, we have a box being moved from point P on a straight line to point Q, covering 20 meters. Now, this is a direction. This is what a direction. If you look at our four cardinal points, we have the North Pole, we have the South Pole, we have the West, we have the East. Now we can say this box moved in the eastern direction in 20 meters, cover 20 meters. So there's a direction, not like random motion. Random motion whereby, smoke particle, motion of gas is just randomly in the air, randomly in the air, randomly in the air. Let's say these are particles. Yeah. So these are smoke particles randomly in the air, randomly in the air. So they don't have definite direction. They are all in different direction, which is different from these, which is, a regular direction, well spaced, well ordered. It is easier to locate the position of a particle when the particle exhibits translational motion. Now, another type of motion is rotational motion. Rotational motion. So, from the word rotation, it means something moving in, how will I put it to make it more easier to understand? Okay, something that has a fixed point and is rotating about that fixed point. Now, something that has a fixed point and is rotating about that fixed point, we can actually define that as rotational motion. An example is, the when you check the wheel. Example, the wheel of a moving car. I'm very sure that everybody has seen a car before. So when you check the wheel of a moving car, it's something like this. I'm not good at drawing, but I'll try. Yep. So something like this. So when the car is moving, you see it's rotating about this fixed point. So we can say this is rotational motion. Also, another example is our fan blade. We'll check the rotation of the fan blade. When you have a fan that is like this, yep, yeah. So rotation of a fan blade. The fan keeps rotating. This blade keeps rotating. So rotation of a fan blade. So a rotational motion is just a motion of an object about a fixed point. So there's always a fixed point rotating about a fixed point. Now, another example, the last type of motion I think I would like to talk about is oscillatory. I hope my spelling is correct. Oscillatory motion. Yeah. Now, oscillatory motion is a kind of motion that is a to and fro motion. It means it's a motion that it moves to and fro, reversing in the direction of the motion. I'll give an example. The motion is mostly periodic, and I'll explain what I mean by periodic. Now, if you look at a pendulum, example. This is a very good example now. Now, when you displace this pendulum, it swings. Maybe you displace to the right hand side first. It swings like this, then comes back to the center, then swings back like this. So this is an example of an oscillatory motion. It's a motion that is a to and fro motion. It's as simple as a to and fro motion, reversing the direction. Reversing the direction. There's a reversal. When you displace it to the right hand side, there's a reversal to the center, then it goes to the left, then it continues like that till it finds its balance. So there's a reverse. Is a to and fro motion, reversing the direction of its motion. And returning to the original position, which is this, returning to its original position. Yeah. So now, just going back, having discussing motion in physics, I said it's the change in position of an object with time. And types of motion, we have random motion, which is not regular, disordered. Then we have translational motion, which is the opposite of random motion, which is regular. There's a direction, there's an order in the movement of the particle. I gave an example. Then we have rotational motion. Then we have oscillatory motion. So right now I will be giving some definition of some terms in motion, because in my next video I'll be doing a lot of calculation regarding motion that has to do with motion. So explaining these simple terms, we give you an hint, or how will I put it? We give you an hint of what the next video is gonna be about, or it will help you to understand what the next video is gonna be about. So let me just say terms in motion. Some physics terms. So for the first term I would like to explain, I would like to talk about distance. Let me just list them. We have distance, we have displacement. So I would like to say the difference between, I'm very sure some people say, what's the difference between distance and displacement? I like to talk about speed. I like to talk about velocity. I like to talk about acceleration. Now, these 5 terms are the basics of you understanding, or being, or of you being able to solve problems in motion, especially calculation problems in motion. And there's this equation of motion. We have 4 basic equation of motion, but I'll talk about that in my next video. We have v equals to u plus at. We have v squared equals to u squared plus 2as. We have x equals to ut plus r at squared. We have s equals to v plus u over t. I think I'm correct here, hopefully. I'm not sure of this, but trying to remember. Yeah, v plus u over t, yes. So in my next video we'll be using these formulas, the equation of motion, to solve a lot of problems. But in this video I want to explain these terms: distance, displacement, speed, velocity, acceleration. Now, first thing first, distance. Now, what is distance? let's imagine, let's imagine there's a movement of this object to this place. Now, something happened, right? From point A to point B. This object moved to this place. Now, something happened. A distance is covered. Now, what's the distance covered? Let's assume 7 meters is being covered. That's just a simple analogy of distance, right? That's a simple analogy of distance. But the difference between distance and displacement is that one has a direction, one doesn't have a direction. Now, distance doesn't have a direction. Displacement. Now let me talk about displacement. By the time I explain displacement, you'll be able to understand the difference between distance and displacement. Now, displacement, there is a specific direction. There's a specific direction. Now, I'll give a very good example. There's a specific direction. Now, if I say, now looking at the four cardinal points. If I say a man moves 20 meters in the north direction, now this is my north direction, moves 20 meters in the north direction. Then and I said the man makes another movement, makes another movement 10 meters in south direction. Now this man moves, I'm clean this off. So that we can understand the difference between direction and displacement and distance. A man moves 20 meters in the north direction. This is our north direction, 20 meters. That is from this origin here, these four cardinal points. From this origin here, it moves 20 meters. Now they said the man makes another movement 10 meters in south direction. That is from here, it moves 10 meters in south direction, opposite direction. Now this is 10 meters. From here to here is 10 meters. From here to here is 20 meters. So this is I would draw out the whole movement of the man. So he moves from here to here, 20 meters at first. Then it took another movement from here to here, 10 meters. Now how many displacement does this guy cover? 10. Just 20 minus 10, which is 10. So we can say that there's a direction in this man's movement because it is being specified. Even though he moved on the same line, but we can point out that he actually covered only 10 meters from the starting point, which was here. Even though he moved 20, then he came back 10. So the total distance he covered was just 10. But if we are going to look at the distance covered, not the displacement now. If we are going to look at the distance covered, because I'm trying to explain the difference between distance and displacement. It is very tricky, but it's easy to understand. So this dude moved 20. Now let me explain displacement. This dude moved 20, then he came back 10. Now, normally, you will say he moved 20, then he came back 10. Normally, you say he covered 30 meters. And I can tell you he covered 10 meters. Now, let me explain the difference between these 30 meters and 10 meters. Now, the 30 meters is the total distance covered. While the 10 meters is the displacement. Now, he moved 20, he came back 10. Total distance covered is 30. Now, the displacement from his starting point is just 10, because when he moved 20 meters, then he came back 10, he was only being displaced by 10 meters. That's it. 20 minus 10 meters. But if you are going to get the distance covered by him, he moved 20, then he moved another 10. So the total movement was what? 30. So displacement is distance covered without a specific direction or of movement. While displacement is the distance covered or distance traveled in a specific direction. So I hope you get the difference between distance and displacement. So displacement is the distance covered in a specific direction, while distance is just change in position, or the total change in position, or the total distance covered, just like that. So let's talk about the next one, which is speed. We have the object that measures speed. We call it speedometer. That measure, we have 60 kilometers, something like it measures like this: 60 kilometer per hour, 40 kilometer per hour. So this is basically reading the speed. So I will tell you how these things work. So when a car moves, it covers a distance, right? It covers a distance, right? Now, it covers a distance in what? In a particular time. So if a car is going to move, let's say it's moving from a city A to a city B, there's a distance covered and there's a time taken to cover that distance. Now, so the speed will be equal to the distance covered by A moving to B all over the time taken. So for example, if I say a car moves a distance of 600 kilometer in 20 hours, so I can tell you what is the speed of the car. So from our formula, speed is what? Distance covered. So this car here moves from this point to this point, covering a distance of 600 kilometer in what time? This distance in what time? 20 hours. So we have 600 divided by 20, that is distance over time. So this, we divide this, so we have 30 kilometer per hour. How did we get kilometer per hour? Distance was in kilometer and time was in hour, so that's kilometer per hour. So you can understand distance. Now, what's velocity? So velocity is similar to distance. Velocity is similar to speed, but the difference, there's just a slight difference. Velocity actually is in a specific direction, just like displacement. So velocity is in a specific direction. It's in a specific direction. So we can say velocity is the change in distance or displacement um, with time in a specific direction. In a specific direction. In a specific direction. So velocity, formula for velocity will be displacement over time. So I've been able to explain this, okay? Explain 4 terms. So the last term is acceleration, which I'm gonna do, and that will bring us to the end of this video. So the next video I'm gonna upload, if you want to understand or see how problems or how these terms are being applied in solving calculations, then you can, put on your notification bell so that when the video is being uploaded, you can always watch the video anytime. So what is acceleration? Acceleration is I need to explain. I'm trying to think of a basic thing I can use to explain acceleration. Okay, accelerate, from the English word, it means it's a combination of 2 things: combination of speed, of velocity, and time. Now, the higher the speed, the greater the acceleration. The lower the speed, the lower the acceleration. So acceleration can be defined. So the relationship between this and this is acceleration, which is defined as the rate of change of velocity with time. Rate of change of velocity with time. That is, A equals to velocity over time, and velocity is given in I want to write the velocity is meter per seconds divided by time, which is s. So that's meter per seconds multiplied by 1 over s. That's ms square, right? This ms square, or you can also write it as ms raised to power minus 2. So acceleration is defined as the rate of change of velocity with time. So I'll be stopping here. Our next video is gonna be about applying these terms, and I've been able to do an introduction to motion. So we'll be solving a lot of questions in the next video, hopefully. And please don't forget to like, subscribe, and share this video if you enjoy the video. Thank you.